Hi, this is Tom, amateur reader call sign N8FDY, and today it's another meter review. This is the second review in the 50,000 count meter group, and it is EEVBlog's 121GW. It's in the Dave Jones No BS packaging. Let's see what we got here. We got the meter, a certificate of conformity, and we have some leads and a thermocouple. Let's see here. Yeah, that's a thermocouple, all right. I don't have a way to accurately measure temperatures, so I can't tell how good they are or not. I do use them, because when you're overheating a part, you don't need to be very accurate to know you're burning it up. But, all right, these are some pretty flexible, maybe not as flexible as ProMasters, but they're not as bad as most. It has the Cat 4 little guards on them, which we'll of course take off, because we're not using this for Cat 4 or Cat 3. We're sticking to Cat 1 and 2 around this house. All right. So, they are not gold plated. So you might want to replace these with ProMasters or not. Well, we're not here to test the probes. We're here to test the meter. So much for these. You notice right off the bat, it's got an internal temperature sensor, and it gives you the temperature in centigrade. There is a way to change that. This has extensive setup function, so you can change a lot of the features. I go through that in the written review. There is a written review at my GitHub site. There's a link in the description of this video that'll take you right to the review of this meter. So all the details are in there. So I may gloss over some things here and may not cover everything, but everything's in the written review. And let's go over the features of this meter. It has a dual 50,000 count display. It has a 0.05% plus or minus 5 basic DC volt accuracy. It has an auto hold measurement. It is 600 volt Cat 3 rated by ETL. It has Bluetooth connectivity. It has an open source cross-platform application software, Android and Windows. It has a 15 volt diode test voltage. It has volt amp power measurements. It has low burden trademark voltage. It has a unique burden voltage display. It has a micro SD card for data logging and firmware updating. We're going to measure accuracy, but we're going to do it indirectly. I do not have direct voltage or resistance or capacitance standards, or current standards for that matter. What I did is I either use an arbitrary waveform generator or a voltage reference like this, and I've measured them with my Keithley DMM 6500, which was calibrated in February, and it's a 6.5 digit bench voltmeter. So that is what I'm using to measure my homemade references. So this was bought on Amazon. This I made myself. This I ordered and picked out as precise of resistors and capacitors as I could afford. And I found some schematics for current references, and I built them with the parts that they specified, and some of them came out pretty even and other ones came out at kind of weird values, but nevertheless I measured them all with the Keithley, and I marked everything. So that's what we're using for references. It's not ideal, but it gets the job done for comparing these meters to each other. In this group of meters, since they're the highest precision meters I've been testing, I did them all in the same room, all at the same time, so they all had the same temperature, as did the Keithley. So we'll toss in a picture of that, and you'll see what we were doing. Anyway, that's how we're doing it. So first, we're going to do voltage. Here's 2.5005 volts, and it reads it as 2.5008. Oh, 009. Here's 5.0009, and it reads it as 5.0015. Here is 7.5016, and it reads it as 7.501. Since this is a 50,000 count meter, when you go over 50,000, 7 is over 5. Everything moves to the right by 1, so you lose the least of a digit. So that's why it only shows 3 decimal points now instead of 4. This is 10.001, and it reads it as 10.002. All the DC voltage measurements I've taken met the specifications as stated in the manual for accuracy. The accuracy specifications are the lowest in this group of 50,000 count meters. I have noticed that if you look at this meter in a 90-degree angle, which would be straight on like the camera is, the contrast gets lower. But if you look at it at a 45-degree angle, the contrast is much better. So let me tilt that up so you can see that happening. So there is a little better contrast now that I tilted it up. And when we tilt it back down, the contrast goes down. And that's the way it is in person too. So if you're using it on the desk, it doesn't really work this way. You got to flip it up and put the kickstand down, and you can see it better. It's time to try some AC voltages. So we switch it to AC, and I use my arbitrary waveform generator to generate some AC voltages. It just so happens that in the specifications for AC voltages of the 5 50,000 count meters I'm reviewing, this one has the most stringent, highest specifications for AC voltage. So I use it as my portable way of getting accurate AC volt readings. Since I'm using an arbitrary waveform generator, it digitally controls the voltage, so it actually does it in discrete steps. So there is no way with the resolution this has that I can get to exactly 1 volt. So this is the closest I can get to 1 volt using this generator. And now we will take it up to 2 volts. Now this is the closest I can get to 2 volts with this generator. And you'll see in the written review, I actually compared the voltage readings in AC with the Keithley versus this. So you'll see what the accuracy is compared to the Keithley. But again, the specifications, this is the most accurate AC voltmeter of the 5. All the AC voltages I tested met the accuracy specifications as stated in the manual. The accuracy specifications for the volts range was the highest in this group of 50,000 count meters. Now we're going to do AC plus DC. That is something special that these 50,000 count meters all do, and it's you could do it on a calculator, but why would you want to if you can have the meter do it for you? So the way we're going to demonstrate that is I'm going to leave the 2 volts AC, and then we're going to switch to DC, and we're going to add 3 volts DC to the signal, and we'll dial this in to be exactly as close to 3 volts DC as we can get it. So we got 3 volts DC. We have 2 volts DC. And now we're going to show you the AC plus DC is 3.6. And to prove that that's right, we're going to use our little calculator here. And we're going to take the square root of 2 volts squared plus 3 volts squared, okay, equals the square root of 13, which in a real number is 3.60555, and we got 3.6054. So this little meter calculates pretty good. So also in the written review I have some more different voltages so you can see how it works. All the AC plus DC voltage measurements met the specifications as stated in the manual. Now we're going to do some current measurements. We got 0.89 microamps. And this shows 0.85. All right, we got 9.21 microamps. And this shows 9.09. This is 99 microamps. And it shows 99.10. This is 131.8 microamps. And we get 131.97. Now we'll switch to milliamps. This is 1.00 milliamp, and it reads it as 99.82. This is 9.96 milliamps, and it reads it as 9.993. This is 99.4 milliamps, and it reads it as 98.76. All the current measurements met the accuracy specifications as stated in the manual. The AC milliamps range had the lowest specification in this group of 50,000 count meters. Let's compare the accuracy specifications for this meter to the other meters in this group. For the voltage and current, the accuracy specifications for this meter was in last place for almost all of the voltage and current ranges, with a notable exception of the AC volts range, where it was first place. It also should be noted that this EEVBlog 121GW and the Bryman BM789 both met all their specifications for voltage and current. The same cannot be said for the Greenlee, the Unity, and the Fluke. The Fluke was very surprising because it missed 3 specifications. The Unity missed 2 in this area, and the Greenlee missed 1 of the specifications in this area. You notice when I switch it back to ohms, it's warning me that I have the leads in the wrong spot. I need to mention that this has a mode memory for each position on the rotary switch, just like the Brymans. So right now we have it in AC/DC. We turn it off, turn it back on. It's still in AC/DC. I can change it back to, I changed it back to DC, turn it off, turn it back on. It's now on DC. I turn it off, turn it back on. And you see it's still on DC. I did find out in the EEVBlog forum that for people who don't like this feature, there is a way to hack the firmware to turn that off, but I don't see why. I'm starting to get used to it. I mean, the flukes don't do that, and that's the meters I usually use. But now that I'm getting used to using Bryman meters and this meter, I kind of like that it remembers. Let's do some resistance measurements. Let's switch it over. The resistance of the leads. It says they're 0.05 ohms. So let's zero this out with the relative function. This is 1.004 ohms. And it shows up as 1.012. This is 10.007 ohms, and it shows up as 10.037. This is 100.069 ohms, and it shows up as overflow. Like many other meters, when you're using the delta function, it locks you into the range you made the delta function measurement in. So this has a 50 ohm range, which most 50,000 count meters, the lowest ohm range they have is 500. But this one is 50, and of course the Fluke 289 also has a 50 ohm range. So we're trying to measure a 100 ohm resistor. We're going to have to take it out of relative mode and go back into auto ranging. And with this meter, when you take it out of relative mode, it automatically turns back on auto ranging, unlike some other meters. So again, this was 100.069, and its reading is 100.33. This is 1.0001 kilo ohms, and it reads it as 1 kilo ohm. Here's 10.002 kilo ohms, and it reads it as 9.999. Here's 100.02 kilo ohms, and it reads it as 100.043. 100.02. Okay. 100.01. Will it go down to 0? Nope. 100.01. Oh, 100 even. Oh, back up. Well, as you can see, it does dance around. Here is 9.97 mega ohms, and it's 9.979. All the resistance measurements met the specifications as stated in the manual. The accuracy specifications for the ohms and kilo ohm range were the lowest or least stringent of this group of 50,000 count meters. All right, now we can measure some capacitance. According to this meter, there's no stray capacitance in these wires, which is suspicious, but I got to go with what it says. Now it says it can measure down to 1 picofarad because 0.001 is 0.001 nanofarad is 1 picofarad. So let's see if we can read this 12.36 picofarad capacitor. It reads it as 0.007 nanofarads, which is 7 picofarads. Here's 102.56 picofarads, and this reads it as 0.101 nanofarad, which is 101 picofarads. Here's a 1.005 nanofarad, and it reads it as a 1.006. Here's a 9.921 nanofarad. It reads it as 9.926. Here's a 99.51 nanofarad, and it reads it as 99.41. Here's a 1.009 microfarad, and it reads it as 1.0093 microfarad. Here is a 10.294 microfarad, and it reads it as 10.85. 10.849. Here's 112.2 microfarad, and it reads it as 110. Here is a 944.5 microfarad, and it reads it as a 980. 984. 5. All right, settled at 993. All the capacitance measurements met the accuracy specification stated in the manual. The accuracy specification for the upper nanofarads and lower microfarads were the lowest or least stringent in this group of 50,000 count meters. I also note that for the 10 picofarad range, the uncertainty value is too large to make that measurement very useful. Well, let's compare all the meters in this group for accuracy with resistance and capacitance. Well, this meter has many of its ranges are the least accurate of the 5 meters, with the notable exception of the high megaohm range, which is the most accurate of these 5 meters. Also note that this meter met all its accuracy specifications, along with the Bryman, and for just these ranges, the Greenlee and the Unity also met their specifications, but the Fluke missed the low ohms specification. Time for some diode checking. This meter has a feature that I haven't seen on any other, is you can choose between 2 different voltages to check the diodes, 3 volts or 15 volts. So when you're on the resistance spot of the rotary switch and you use the mode to go into diode check, when you press the range, it changes the voltage from 3 volts to 15 volts. Hit the range again, it goes back to 3 volts. And it shows you up here on the secondary display what voltage you're testing with. So 15 or 3. And you notice that the LED gets a lot brighter when you put it on 15 volts. And then put it back, but it still reads the same. Well, it reads a little more forward voltage, and there's definitely more current going through. So the LED, yellow LED is working, but it's a little dim. Let's go to the higher voltage. Oh, all right. Let's try this. The green LED is really dim, but let's kick it into high mode, and there you go. Very handy. And of course, we'll do the Schottky diode. There's the Schottky diode with the forward voltage. Let's see if any voltage makes any difference. Oh! That was weird. There is the small signal diode. Let's see what happens when we... And here is the rectifier diode. Now there's an interesting function with continuity. If you rotate through the setup functions while you're in continuity mode, you'll find a mode that says what DN30. And DN30 means I beep when I short, and I will consider a short 30 ohms or less. You can change that by holding down the setup until it blinks, and then you hit this up arrow, and now you're telling it to beep when you're open and the beep at 300 ohms or higher. Now you're telling it to beep when you're shorted, but consider anything below 300 ohms as a short. And this mode is beep when you're open and consider 30 ohms as the threshold for being open. So we'll set it back to normal. And then to save it, you hold down the setup button until it stops blinking. So that's very handy. let's get out the probe masters for doing continuity checks. I'm thinking a meter with this much features in the continuity check to customize it. It probably is fine, but let's see. It's definitely latched. Let's see how fast it'll go. All right, it goes fast, latches. Too bad it doesn't blink, but it's all right. It's fine with me. Oh, you might want to see how it works with opens, huh? Let's try that. So now it doesn't beep when it's shorted, but beeps when it opens. It's for testing open wires. All right. Okay. I can't show you here, but I'll show you pictures. This has a unique function where it can measure volt amps, or power in DC, volt amps in AC. You hook up 3 wires and you can measure. It'll take the voltage times the current and tell you what the product is on the screen. And it's pretty handy. Like I said, I show you a picture. It's also in the written documentation of the values, but no other meter that I've tested does that. The closest I have to that is the Keithley DMM 6500 can actually do 2 measurements at once, depending on the measurement. And I was able to set it up to do voltage and current at the same time, and you wire it up very similar to the way you wire this up to do power or an AC volt amps. And it's quite interesting. It's a handy little feature. This has an extensive setup function, and in the written documentation I go through what those are. This is the first of the 50,000 count meters that has a logging function. And it's unique in that it actually has a micro SD card inside of it that you can log to that. So you don't need any external connections, and you can just push the memory button, hold it down, and it'll start logging. And it'll keep logging until the card fills up or the meter goes off. And it disables the auto power off while it's logging internally. But that isn't all. You also can log with Bluetooth. The logging interval in the setup only applies to the logging to the SD card. The logging that happens on Bluetooth is up to the Bluetooth application. There's an application called Meteor for 121GW that you can find in the Apple Store that'll load on my tablet, and I load it on the phone, and it can talk to this. There's also a Windows application that you can get from the Windows Store, and I was able to run that application on Windows 11, the ARM version running under Parallels on my Mac Studio. So I thought that was interesting, so I was able to talk to it that way. Now I also have an Android tablet that's running Android 12L, and the Meteor for 121GW will not load on that. It says that the device is too new or the software is too old, however you want to put it. And the EEVBlog Android app won't load either on that. So I guess you need an older Android to run those apps. So I couldn't test that. Anyway, I think the logging is very interesting, and This is the smallest meter I have that does logging, and which is convenient, and it also has pretty long battery life. With the 4 AA batteries, you get about 500 hours in the it claims in the manual. So that definitely beats the Fluke, and I'm pretty sure it beats the Unity, but I don't know if it beats the Greenlee. We'll have to see. So anyway, if you want logging that can be totally isolated on a SD card, and of course to get to the SD card, let's turn off the meter. You have to take the boot off. And this is the same thing if you want to change the batteries or change the fuses. It's all the same. There's 2 captive screws, which I like because I lose screws a lot. So I definitely appreciate captive screws. Anyway, there's 2 captive screws. Let's see if we can get this off here. And you open it up. And in here is the 4 AA batteries and the 2 fuses. And right here is the SD card, which if your fingers are small enough, you can take out. So you can log to this and then take it out, and in my case, load it into the Mac and read it in Excel. It's a CSV, and it opens it right up and shows you the data. So we'll just put it back in here. And this SD card, this micro SD card came in the meter already, so it's included in the meter. So that is pretty cool. And of course, I always appreciate being able to change the fuses without tearing down the meter. And let's just put this back together. And it's, of course, going into brass inserts, so you still don't want to over-tighten. Over-tighten is not good, but it's definitely more reliable and will last longer than going into plastic. So I appreciate that with this meter. And slip the boot back on. There you go. Let's go over some of the pros and cons of this meter. The good part, it's third-party safety tested by ETL for US and Canada. The AC volts accuracy specification is the highest in this group of 50,000 count meters. The high mega ohm accuracy specification is the highest in this group of 50,000 count meters. All the measurements taken met accuracy specifications in the manual. Micro SD card and the Bluetooth logging. It remembers the last mode used on each switch position. It has a setup menu to customize many of the operations. It has a useful secondary display. It has volt amp measurements. It has a built-in aperture temperature sensor, and the fuses can be changed without disassembling the meter. Now, some of the not so good parts of this meter. Most ranges are the lowest accuracy specification in this group of 50,000 count meters. It only measures up to 600 volts. So if you're doing boat anchor work, you may have a problem. But for everybody else, that probably isn't a problem at all. You must send it to Australia for service. That's not much difference than some of the other meters that you have to send to Taiwan. Or the Android software doesn't work on my tablet, which is 12L, so it probably won't work on anything newer than that either. The red writing around the rotary dial is very difficult for me to read. My conclusion. Well, this meter is definitely a dichotomy. It has many features I like. It has unique features that's not on any other meter, such as the micro SD card, the VA measurements. It has other things that are handy, like the Bluetooth logging, and it's light and small compared to the other 50,000 count meters. But it is the lowest accuracy specified meter of the group. And maybe this accuracy, if the accuracy this can do meets what you need, then that isn't a problem. It is definitely, you'll get more accuracy than a 6,000 count meter. But of this group of 5, it is the least accurate specified. Now, in my random sample of 1, it usually was much closer than what the accuracy specification said. And again, it met every one of its accuracy specifications. For 3 out of the 5 meters, I can't say that. The 3 higher cost meters, they all missed at least one of their accuracy specifications, and some of them missed a few. So it's great to have a highly specified meter, but it's not so great if that meter can't meet that specification. So this guy met all its specifications. So did the Bryman 789, but the Bryman 789 doesn't have logging. So if you want logging, you could get this. Now, if you want to work with Bluetooth on Android, I couldn't get that to work. You know, the tablet I have is a couple months old. I actually got it just so I could test Android logging software, but I do use it also for camera control, because the cameras I use, the Android version of the software works better than the iOS version. So, you know, I may like Apple just like I may like Fluke, but they don't do everything right. And so you got to be open to other ideas, and I am. So I definitely think you should consider this meter, and if you can live with its constraints, it's a pretty good meter, and it's only $225. I got it off of Amazon. Of course, you got the 30-day Amazon return. And, you know, if it does have problem under warranty work, it says to contact EEVBlog. So I'm guessing you send it to Australia if you need to get it fixed. I'm not 100% certain of that, but that's who you contact for support. So, but this is a unique meter that you can't buy any other way, and it is a very interesting meter, and I'm going to keep this meter. A lot of these meters I'm going to sell at Hamfest once this project's over, but this is one of the ones I'm going to keep. Anyway, I hope that helps. And this is Tom, N8FDY, saying 73, and take it easy.